Hello everyone, my name is Saurav and today I will be presenting on how to simplify a linear regression model. Linear regression models are used to predict the relationship between two variables, but sometimes these models can become complex and difficult to interpret. How can we simplify them? One way to simplify a linear regression model is by using feature selection techniques. This involves selecting the most important variable or feature that have the strongest impact on the outcome. We can use this method as forward selection, backward elimination, or stepwise to identify the best feature for our model. Another way to simplify a linear regression model is by reducing the number of variables. This can be done through dimensionality deduction techniques such as principal component analysis, PCA, or other factor analysis. These techniques allow us to compress the information from many variables into a smaller number of components or factors. So, by simplifying our linear regression models, we can make them easier to interpret and understand. This can help us to identify the most important factors. Okay, so let's have this chart here. We have this spreadsheet, which is the home market value. We have the dependent variable of X and Y. Like market value is a dependent variable and square feet is an independent variable. Is square feet market value is totally dependent on the square feet as we know the value of the market depends on the square feet of how long the land is. So we to understand the relation between these two variables, we have done this data analysis of generating the linear regression model, and we have this answer, right, summary output. Now what we see here is the data analysis. As the data analysis, that the multiple r square, adjusted r, standard error. We have the standard error as well. So let us see each one of this, how it is described. First of all, let me tell you something that imagine if you want to buy a house. You know that a bigger house is measured in square feet. So the more expensive it will be, the more expensive it will be, the more market value it will have. Now imagine that you have a lot of data about different houses, their sizes in square feet and the market values also. You can use this data to create a regression model. Okay, so the first is the multiple r. So the multiple r value we have here is 0.73125. It means that there is a positive relationship between the size of the house and the market value. This means that as the size of the house goes up, its market value tends to go up as well. Now we have the r square. The value of the r square is 0.53. Means that about 53% of the variation in the market value can be explained by the size of the house. This means that the model is fairly accurate in predicting the market value and based on the size, but there is still some other factors that influences the prices. Like we have, if the location is very good, if there is a green environment, if there is a hospital nearby. So these are the factors which could affect the prices of the market, price of the land in the market. So that is why we have the reliability of just 53%. Now next we have the adjusted r square, which is of 0.52, which is similar to r square value but takes into another account of the variables in the model. It's slightly lower than the r square value, which means that adding more variables might not improve the accuracy of the model by much. That just I said right now, but because whenever there is some other factor included in the price of the land, there could be something like hospital nearby or marketplace is nearby. The prices of the market value depends upon these variables as well. So there is only 53% of the explainable. We have this variable. Now we have the standard error. Now the standard error value is 7,287. Now what this means? The standard value is a measure of how we accurate the prediction of the model. The lower the value, the more accurate the model is. So it is likely in this case the value is fairly high, which means that the model's prediction might not be always be accurate. Okay. And the observation we have 42. This is 42 variables we have here in this sample. Now the second one is ANOVA model. We have the ANOVA tables give us some more detailed information about the model. We have first the F value. The F value is 45.97. It is measure how well the model fits in the data. The higher the value, the better the model fits the data. Now we have the significance F. The value of 3.8, this means that the model is statistically significant, which means that the relationship between the size of the market and the value is not likely to be due to chance. Okay, so finally the observation value is 42, tells that the point we have created to use this model is 32. In summary, we can say that this regression model analysis tells us that there is a positive relationship between the size of the house and the market value, that the model is fairly accurate in predicting the market value based on the size. However, there are other factors that can influence the price as well. The model's prediction might not be always be accurate, as there is only 53% the explainable variable we have got in the adjusted R square. So this is all for this data as for this. One thing to be noted here, excuse me, that uh, p-value, we got this p-value as 0.006. It is less than, so it is more than 5%. No, it is less than 0.5. So we can say that the p-value is fairly accepted. The null hypothesis is accepted as it is less than 0.005. And we got this, and we don't have anything else here. uh Everything is explained well.